Welcome you all in this lecture. We are going to discuss a brand new topic. The topic of the today's discussion is effective stress principle. This is actually there in our syllabus in the subject geotechnical engineering. It is there in Unit 2, Chapter 4. So now actually what we are going to discuss in the beginning, we are going to discuss effective stress principle. Actually, the term effective stress is coined by a great professor, is supposed to be called as father of modern geotechnical engineering, is undoubtedly Terjagi. So now we are going to discuss about Terjagi's effective stress principle. So initially we discuss effective stress principle. Later we think about how to determine effective stress for different ground conditions and also different loading condition. So let us proceed now. Here in this class, we are going to discuss effective stress principle. As you know, here you see we have a ground surface here. Let me show you. So now our interest is to determine stress at any point within the ground at a depth z. Now how to determine stress now at a depth z right from ground surface, also called ground level. So now it is very interesting to know, we know unit weight of the soil, gamma. Now what is the stress here? Gamma into Z, gamma into Z. So Z because that is the depth I am considering right from ground level. So gamma into Z. And somebody is very much interested to know what about the stress at the top, ground level. It is zero because gamma into zero, where depth is zero because we are trying to calculate the stress at ground surface. If it is gamma into zero, it becomes zero. Now gamma into 1, now gamma into 2, like that, if it is depth is 10 meter, I can write gamma into 10. Now if you see here, if you join the extremities, ends of this, what I say values, we will get a straight line. So from this, we can easily understand stress is increasing linearly. As the depth increases, stress is increasing. It is true. So, in general, we will accept. Here you see, stress at this depth is less as compared to deeper depth, because here the depth is more, gamma into 1, here it is gamma into 10. So that's, but here you see the stresses developed within the soil is due to its own weight. Here you see I'm telling about its self weight. Gamma is the self weight of the soil, or sometimes you see there may be external pressure, external loads, stresses developed within the soil mass due to external loads. Also, this is we call stresses due to applied loads that we use to discuss in foundation engineering. Right now, our discussions are confined to stresses due to self weight of the soil. That is gamma at any depth z, gamma z. This I would like to call sigma. So we are designating total stress with sigma. So now let us proceed now. What is total stress? Here you see the total stress is either due to self weight or due to external load. But here our discussion is about due to self weight. So that's why we are trying to call sigma is equal to gamma into z. So one can easily understand total stress is equal to force by total area. Total area. Now we have neutral pressure, also called hydrostatic pressure, also called in is very popular word pore water pressure. U. So sometimes, so many times we know we have soil having solids. Within solids, we expect pores. Pores also called voids. So within voids, you can expect water. So the pressure exerted by the pore water is called pore water pressure. If we insert a piezometer, you will get the head of the water, HW, head of the water. Now, what is pore water pressure? U is equal to gamma of water into height of water. See here, I am trying to tell you. Here you see, HW is the height of the water. So how to determine now pore water pressure? Pore water pressure is also called neutral pressure, which is equal to gamma of water into height of the water. Now you see many times we used to know once you remove the pore water pressure, particles will comes in contact. The grains, solids, particles comes in contact. Now the stress originally acting between the solid particles is the original stress. So that is nothing but effective stress. Now you see we have a total stress sigma, we have a pore water pressure u. Now Now we are discussing about original stress acting within the solids, within the grains of the soil mass. So now how to get it is sigma dash is equal to, so this I am trying to call effective stress. Effective stress means the original stress acting between the particles of soil mass. So that's why it is called effective. The right word, many times we used to see a book like Holz and Kovacs, where he used to mention intergranular pressure. The right word is intergranular pressure. One can use intergranular pressure, the term intergranular pressure, as a synonym to effective stress. Now, sigma dash is equal to sigma minus u. So, total stress minus pore water pressure, that gives the effective pressure. In fact, you cannot measure this. You cannot measure this. Total stress you may measure with some pressure gauge. You can measure the pore water pressure by inserting piezometer, but effective stress is an imaginary quantity. It's a fictitious quantity. It cannot be measured. It has to be calculated only. How to calculate effective stress? So now effective stress is the original stress acting between the particles. Now how we are getting sigma dash is equal to sigma minus u. What is sigma? Total stress. I can write without any hesitation. Gamma into z minus pore water pressure. If it is a dry soil, pore water pressure is zero. Gamma d into z. So, this is what I would like to tell you in the beginning of this chapter, and also very important, effective stress given new dimension to soil mechanics, because many engineering properties like consolidation, what I say, compressibility of soil, shear strength of soil, they are function of effective stress. Here you see compression and shear strength, they are utmost important engineering properties of soil. They depends on effective stress. We realize very soon when you are discussing consolidation and shear strength of soils. So this is about introduction to effective stress.